So it is your first day in the class, right?
Yes, sir.
Oh, okay. So you have joined recently only.
Yeah, today only.
Okay. So in earlier classes, we have discussed integration
Oh,
and we have done integration formulas, understood the concept of integration. We have also discussed integration by substitution.
okay.
And yesterday's class, we discussed integration by parts.
Okay.
So please do cover that with syllabus. And if you have further problem, then you may ask anytime. And also, we have already covered limits, continuity and differentiability, differentiation and application of derivatives chapter.
Okay, sir.
It's 6:05, so let's start. So before starting and discussing about the partial fractions, is my voice audible?
Yes, sir.
Yeah. So before starting about the discussion about partial fractions, first let's see these two terms. As we can see, and if we like further solve these two, then it will come out like this. Hmm. So these are two same expressions expressed in different forms, right?
Hmm.
So if we integrate these two, and if we integrate this, so the integration of this and integration of this, which would be more easier and convenient for us, first form or second form?
Hmm. Maybe second form.
No, actually first form,
Okay.
because we know the formula of these form, as we have earlier discussed about the formula of integration, in which we know that integration of 1 by x dx is ln of x plus c. So similarly, and so in this format, we are better able to solve this particular integration. So if we see the process in reverse, that if some function is given in this format, second format, then if somehow we'll be able to convert it into the first form, so we'll be able to solve this question, the partial fractions question, very easily. So this gives a birth to the concept of partial fraction, where we go backwards in like we convert the function from form second to form first. Partial fractions. Basically, if a function is of the form px by qx, where px and qx are polynomials of degree m and n. So there are two kind of rational fractions. Uh, there are two kinds of fractions: partial
Okay.
fraction or improper. Proper fractions and improper fractions. Proper
Perfection.
fractions are those in which the degree of numerator, let's say the degree of numerator is m, degree of denominator is n. So if the degree of numerator is less than the degree of denominator, so they are known as proper fractions. Otherwise, they are known as improper fractions. So we are going to discuss about this concept about proper fractions. So if there is some like improper fraction, then we can easily convert that in a proper fraction format by like this. If px and qx, if this is the case that the degree of numerator is greater or equal to the denominator, so we can further solve it, and some like let's say x square plus x plus 1 upon x square plus x is it is the case. So degree is same. So what we will do, we will simply write separatively the numerator in separate formats. So this becomes 1 for the 1 plus square plus x. Now we will be easily able to integrate this format. That's
Okay.
the concept. So now we will be discussing about different techniques using which we can write functions from this format to a segregated format. Okay.
Okay.
Yes. So let me read a definition from my notes. In this section, we show how to integrate any rational function, that is a ratio of polynomials, by expressing it as a sum of simpler fractions called partial fractions that we already know how to integrate. Okay, so we are simply breaking that fraction into partial fractions so that we'll be able to better integrate them because we already knew about their formulas. So these are some form of rational fractions.
Okay.
Here, the degree of numerator is like this is linear polynomial. This is quadratic, and this is also the same. But here, as you can see, there are two different roots of the quadratic equation, the denominator. So where a and b are different, so we can simply write them as this. So you'll be able to better understand it after we will solve the examples and question. So first, just uh, see them. What we are actually doing is, let me write, let's solve this question. Okay, so what we are doing first is that we'll just take this function out of the integration. Let's simplify it first. And before doing that, first we need to find out like the roots of this so that we'll be able to better write the LCM. Okay, so what we will do for finding the cube roots of any cubic equation, we generally use the hit and try method. So putting x is equals to 1, 1 minus 6 plus 11 minus 6. So yeah, it is easy. Uh, 11 plus 1, 12 minus 6 minus 6, 12. So it comes out to 0. Our first hit and trial is a lottery. Basically, most of the time it is plus minus 1, plus minus 2. This must be the one of the root in the cubic equation because it will be given in the question. So they will make such questions that whose root is easily we can find out that. Okay. So if we know that one root is x is equals to plus 1, so we can simply divide sorry, it will be next this minus 1. We can simply divide the remaining so that we can have other roots. So this will become x square cube minus x square. Yes. Let's change the signs. This cuts this minus 5x square plus 11x minus 6. Now, how we are doing it? We are just checking this and how we can completely divide this first term having highest degree. Okay, we are just focusing on this. So, to which term or to which number should we multiply x so that we can completely get minus 5x square? It should be minus 5x, right?
Mm.
Minus 5x square minus minus plus 5x. Sign changes. This cancels this. And this becomes 6x minus 6. So simply if we just multiply it with 6, so it will be 6 minus 6 and this will cancel both. Remainder will be 0. So now we know we can represent this as x minus 1 into x squared minus 5x plus 6. And now we can see we can find out its root easily, that there must be two numbers whose multiple should be 6 and whose sum uh, should be 5. Okay, so 2 and 3 are such. 2 threes are 6, 2 plus 3 is 5. So if we have these two roots, so we can further represent this equation as x minus 1, x minus 2, very okay. And if you are preparing for NDA, I suppose you must remember this cubic equation, which is very general in use.
Okay.
Anyways, if you don't, there are still methods to learn this, to find out this. Yeah. So now how we can write, this further? We have modified the cubic equation down. So now we can it can be simplified in some forms, like we'll take x minus 1. There will be something coming up if x minus 2 is in the denominator of second, c is minus 3, right? So we take the LCM, a into x minus 2 into x minus 3 plus b into x minus 1 to x minus 3. If you have any doubt that how like using what logic I have written such terms, then you can ask anytime, okay?
Okay, sir.
So now we can see on the both end sides the denominator is same, so it will cancel each other. Now we have simpler form 3x plus 2 a into x minus 2 x minus 3 plus b into x minus 1 x minus 3 plus c into x minus 1 x minus 2. So what we have done here, our purpose was to uh, write this form of given function in some forms, that this function must be equal to this, but we do not know specific values of a, b, and c. So that's why we are equating it and solving it further. Now what we will do further is we will hit and try how that will let the value of x, we will let the value, so here we will let the value of x one by one. We will first take the value of x is equals to 2. So there will be like two terms straight will be cancelled. So there will be only b remaining in the equation. And after that, we will, after finding the value of b, what we will do, uh, Gaya. So first we will let x is equals to 2. So after letting x is equals to 2, so this term will be 0 and this term will be 0. So left hand side will remain, left hand side will be 3 into x, which is 2 plus 2 is equals to, this is 0, so 0 plus b into 2 minus 1, that is 1, 2 minus 3, that is minus 1, plus c, and this will also be 0 because x minus 2, 2 minus 2 is 0, and 0 multiplied by anything will be 0. So further simplifying it, 3 to the 6, 6 to 8 equals to minus of b. So b's value is minus of 8. So we have the value of b. Similarly, we'll find the value of a and b. Let's let x is equals to 3.
Okay.
Yeah. So 3 into 3 plus 2 in the left hand side. On the right hand side, this will be 0 and this will be 0. So c into x minus 1, which is 3 minus 1, 2 into x minus 2. So 3 minus 2, it will be also 0. Sorry, 1. 3 is 9, 9, 11 is equals to 2c. 11 by 2 is the c, right? So now
Yeah.
we have b is equals to minus 8, c is equals to 11 by 2. So let x is equals to 1. When we let x is equals to 1, this will be 0, this will be 0, and this will become 3 into 1 plus 2, that is 5. 5 on the left hand side, and a into 1 minus 2, that is minus 1, 1 minus 3 minus 2. So minus 2 into minus 1 will become 2, it will be 2a. So a's value will be 5 by 2. Okay. So if we Let's save some labor. Okay. So now we have the values of A, which is 5 by 2. The value of B, which is minus of 8, I guess. Yes, minus of 8. And C as
11.
11 by 2. C as 11 by 2. So if this integration was happening, so we can similarly write integration of 5 by 2 into x minus 1 dx plus integration of minus x minus 2 dx plus integration of 11 by 2 into x minus 3 dx. Are you able to understand that how we have done and written this?
Yes, sir.
So taking the constant out 5 by 2, logarithm of x minus 1. Let's write the constant. तीनों के constant एक साथ लिख देंगे. We will write the constant of all these three integration together. Minus 8 outside, logarithm x minus 2 plus 11 by 2 logarithm x minus 3 plus constant, which is like from C1 plus C2 plus C3, which was the constant of all these three integrations. So now this becomes our answer.
Okay.
Yeah. So what we have simply done is that we have just changed the representation of function, which was given to us, and using the partial fraction technique. Because of its lengthiness, it has been seen and observed that in NDA mathematics paper, partial fractions questions has been seldom asked or like rarely asked. So don't drop this, but also don't practice this much because this consumes a lot of time. And even if it will be asked, then it can be asked in like format of 3 questions or something.
Okay.
So next, let's discuss about some a type of integrations. So the first type of integration is simply that first of all we know what if we have to do something with the already available resources, then first we need to know what we have completely, right? If let's say if we are in jungle and if we have some tools, so we must know which tools we have and what is their use cases. है ना? That's when only we will be able to best utilize them. So before reading and understanding all these types of integration, it would be convenient if we will learn all the standard results and formulas of integration, then we'll be able to understand it at the best level. So in this type of questions, what we will be trying to do is that we already know the formula of this x square plus a square x, or dx upon a square minus x square, or dx by x square minus a square, or dx by a square plus minus x square. We already know the formulas of these, and we also know the formula of this. So such terms formula is already known to us. So we will try to make the given question in the same format. How? That we will basically, what is happening here, the variable is having a square and it is separated with the constant. So we'll try to do the same here. We will try to make perfect square of variables in one side and constant in other side. So how we will do that? We'll do that by making perfect square of the denominator. Okay. And in the case, here in the third case, we will make the perfect square of ax square plus bx plus c. And how we will do that? First of all, we have to make the coefficient of x square 1. So we will take the a as common, b by a, x plus c by a. After doing this, what we will do is that we will 1 minute. Let me ensure peace. Okay. So what we will do, we will simply see the coefficient of x and we will half it, and we will, after halving it, like b by 2a is the half of coefficient of x. After halving it, we will square it and we will add it once and we'll subtract it once. So now this will, depending on the sign of this will somehow using this term, and either of these two terms. Using these three terms, we'll be able to make some equation of a plus minus b square, and we'll write in this case, we can write a x plus b by a, b by 2a whole square. So its whole square will be x square plus b square by 4a square, okay, plus 2b, 2 will cancel, plus bx by a. So these three will be consumed. The remaining will be the constant, simple. So it is the basic theory behind doing this all, and you will be able to better understand when we will solve the examples. Okay. Let's solve an example. This is the question. So according to our Siklai, our learning, we'll have to make a perfect square of this format. We will take the coefficient of this, half it, that is 1, and we will square it. After the square of 1 is 1 itself, and we will add and subtract it so that it have nullify effect on our function. So now if we see x square plus 2x plus 1, it's making an expression that's x plus 1's whole square. Okay, the remaining will be written as same, x plus 1 whole square, and remaining is 5 minus 1, that is plus 4 into dx. Okay, so now x plus 1 whole square. Now we will write 4 as 2 square for our convenience, because we have learned the standard results, which was the integration of a square plus x square yeah, so we have learned this as 1 by, sorry, x by 2. Yes, so continue. So we already know the result of this this equation, and this is a standard result. So the answer is x by 2 square root of a square plus x square plus a square by 2 logarithm of x plus x square plus a square. Okay, so we'll use the same results over here also, where a is 2 and x is x plus 1. Okay, so just to understand, x by 2, which was x1 by 2 into x plus 1 whole square plus 2 whole square plus logarithm a square, which is 4 by 2, which is 2. 2 into logarithm of x. Sorry, x is what? X plus 1, right? Plus 1 plus c, which is the constant of integration.
So this is our answer. Yeah.
So basically, we have already, like, we can also apply this method, or like we can also think for this method in exam time, but it would be better if we learn these methods before going to exam. Okay, please now observe the question and absorb what we have done. Is that simply we have made its perfect square here, and then after doing that, we have converted this given format of function in the format which we know how to solve. Okay. Okay, so this is another format. Here in the denominator, there is a quadratic equation. So not equation, expression. And in the numerator, there is a linear expression. And this same method will be applicable in this format also, where the quadratic expression is having an underscore on it, and where, and also applicable on this where these two are getting multiplied. So basically what we will be doing is that we will be representing px plus q in such terms that it will be having differential coefficient of the denominator, or ax plus bx plus c in the case of third. In the case of third, because it's his, the denominator is 1. So we'll better understand it using an example. X plus 3 divided by x square plus 4x plus 1 multiplied by dx. So it is the same. So now what we'll try, we'll first differentiate it. Its differentiation will be 2x plus 4. So we will try to represent the numerator in its form. So it is already 2x plus 4. So how we can make 3 as 4? We'll simply, what we'll do? Do you have any idea what we'll do to make 3 as 4? Mathematically, we won't do magic. Simply we will plus 1 and minus 1, so that a 2x plus 4 will be there in the numerator. So now 2x plus 4 minus 1 upon x square plus 4x plus 1 to dx. Now, let's segregate these two terms, like 2x plus 4 divided by x square plus 4x plus 1 dx minus integration of dx upon x square plus 4x plus 1. So now this has become the same method, the same type of question which we have just solved. Okay. We have solved similar question here. Simply we will make it a perfect square, then it will be easily solved by using those standard results. So yeah, here and about here, what we will do is that we'll consider this ax square plus bx plus c as written here also in the यहाँ पे लिखने का let me write. Then let ax square plus bx plus c as t. Okay, so here we will let's do it on the next page. Let t is equals to x square plus 4x plus c. For integration first only. This is the integration first, this is integration second, and integration second can be easily solved using the same method in which we'll make perfect square. So yeah, after doing that, let's differentiate this equation both sides with respect to x. So this will become 2x plus 4 plus 0. For x square plus 4x plus 1 का 1. So now this has become dt is equals to 2x plus 4 into dx. Now if we look back into integration first, 2x plus 4 into dx is has become now dt. So this is dt divided by square root of t, right? So this is integration 1. So this has become t's power minus half. So we know the formula of integration, the power rule of integration is this. So t minus half plus 1 minus half plus 1 plus constant of integration. Here also plus constant of integration. So it will be further written as t half upon 2 plus c. So 2 square root of t plus c. Now we will back substitute it. What was the t? T was x square plus 4x plus 1 plus constant. So this is integration first. Let's solve integration 2 also. Integration 2, which is what? dx by square root of x square plus 4x plus 1. So for making this perfect square, we simply add the halves. What is half? Is 2. Its square is 4, and we'll subtract it also. So now if we see that it has become x plus 2's whole square, x square plus 4 plus x square plus 4 plus 4x. Yeah, 2x into 2 will be 4x. So now we can write it as x divided by square root of x plus 2 whole square. What was remaining? 1 and minus 4. Minus 3. Okay, so let's write this also in the format of square and minus root 3 square. Okay, so now this is a format. This is a standard result. You can use this x square minus a square, which is 1 by 2a ln of x minus a upon x plus a plus c. Okay, is this clear? Like till this, till yet what we have solved, is this clear to you?
Yes, sir.
So what is A here? A is
Root of 3. Actually, we have confused this formula with different one. This formula is of dx upon x square minus a square, and its formula is what? Its formula is simply logarithm mod of x plus square root of x square minus a square. So this was a confusion. And कहाँ थे हम? Here we were. So we have represented this question in this format. Let's now solve it further. Okay. So integration 2 becomes logarithm of mode of x, which is x plus 2 plus square root of x square, which is minus a square. A square is 3. A is root 3 and a square is 3. So this has become our integration 2. So integration 1 plus integration, the capital I will be I1 plus I2. So I1 was 2 square root of x square plus 4x plus 1, and going back integration 1, and there is a negative sign here. There must be a negative sign here also. Logarithm of x plus 2 minus, oh sorry, plus square root of x square, sorry, plus 2 whole square minus 3 modulus plus c constant of integration. So this is the answer. I could not write it in the same line because of this. Yeah, so this is the answer. This is how we solve it. So is this clear?
Yes, sir.
Okay, so this was type second. This is the type third, which is important. Now, if any function is given in this format, x squared plus minus 1 divided by x raised by 4 plus kx square plus 1, sorry. Yeah, x raised by 4 plus kx square plus 1 multiplied by dx, where k is any constant, can be any constant. So in this, when this format is given to us, so what we will do, we will divide the numerator and denominator by x square. After doing so, we'll put x minus 1 by x is equals to 3 in the case when there will be a positive sign in the numerator, and if it is a negative sign in the in the numerator, then we'll put x plus 1 by x is equal to 3. Are you able to understand this?
Yes, sir.
Yeah. So let's take an example. Integration of x square plus minus 1 divided by x raised to the 4 plus kx square plus 1 into dx, where k is any constant. Oh, I've written the type of writing 1 minus x square divided by x raised to the 4 plus k 1 minus x square x is yeah 1 plus x square plus x4 into dx. This is the question. Now earlier, as we have discussed, so we will first divide the numerator and denominator by x square. We'll take it common, 1 by x square minus 1 x square again. So 1 by x square plus 1 plus x square into dx. This cancel this. So now 1 by x square minus 1 upon 1 by x square plus x square plus 1 to dx. Okay, so now as there was a negative sign in the parent function, so we will take t as x plus 1 by x. So after doing so, let's differentiate it on the both sides, dt by dx with respect to x. Differentiation of x will be 1. Differentiation of x raised to power minus 1 will be 1 by x squared, because differentiation's power rule formula is and that's why we have written so. So now if we see dt is 1 minus 1 by x square into dx. So this is similar to this. So this has become simply minus of dt in the numerator, and here if we will see, so this is what this is basically x plus 1 by x whole square. You will open it up, it will become x square plus 1 by x square plus 2 into multiple of this. So if there will be like 2, so uh, let's make here 2 and subtract 1. So this has become x plus 1 by x whole square minus 1. Are you able to understand that why we have done so? Because to
Yes, sir.
make it perfect square. So x plus 1 by x is what? Is a t. Is a t. So let's write t instead. So now we have differentiation of dt upon t square minus 1 square. So which is of the same format dx by x square minus a square. Its formula is that what we have written it by mistake 1 by 2a earlier, logarithm of x minus a upon x plus a. We'll apply the same 1 by 2a is 1, logarithm of mode of x t minus a t plus 1 plus c. We will back substitute uh, the value of t. The t was x plus 1 by x minus 1, x plus 1 by x plus 1 plus c. So this is our answer. Let me check the answer is correct or not. Oh yes, yeah, it is correct. Okay, so this is about the example of the last type which we had to discuss in today's class. Do you have anything particular to ask?
No, sir.
Any doubts? Nothing?
No, sir.
So till still the time is remaining, so let me discuss more examples.
Okay,
Okay.
sir.
Were not there in the substitution class. So let's solve those questions which were not solved earlier also. Integration of logarithm sec inverse. Okay. A logarithm of sec inverse of x into dx divided into dx divided by x into square root of x square minus 1. So this is the case here. So now we have to make some substitution and we have to reduce this function in some format where we will be able to use our direct tools, whichever tools we have, whichever formulas we have learned till now, so that we can employ those tools and those formula, we can solve that question. So during substitution, there is a trick. It's like there's a bigger function given, like there is a bigger function, and there will be some smaller functions here that fx, hx, I of x, somewhat like this. So you have to just observe all these functions. You have to correlate them in such a manner that find their substitution. Let's, if you're seeing f of x, so try to see if h of x and I of x is theirs, is its derivative. So if f of x is there and if f dash x is also there in some format, then observe that and let f of x as t. Otherwise, if h of x is there and its derivative is present in I of x or f of x, then let h of x as t. Okay, let me do that and make it easy for you. I guess you must have learned integration in your class 12, right?
Actually, not fully, sir, because just now they're going to start. I'm in 11th, so that's why.
So you are in 11th class.
Yeah,
Okay, great. Good dedication. So the differentiation of sec inverse of x is what? 1 by x into x square minus 1. So are you able to see this format in this question somewhere in this function? Is is this term somewhere present in the function?
because the denominator is same as the same, like x root x.
Yeah, right. So let's take sec inverse of x as t. So this has become dt by dx. Now dt is what? Dx upon x into square root of x square minus 1. So now dx upon x into x square minus this has become dt. So we can simply write logarithm of t into dt. Simple. Now this function is very easy to integrate because we know its formula is 1 by t plus c. And 1 by sec inverse of x plus c is the answer. Right.
Yes.
So this is how easy it is. No, actually it's not that easy. We have made a mistake. The differentiation of logarithm of x is 1 by x, not its integration. Actually, the integration of this is we have to find out by using the integration by parts formula. So logarithm of t. So if by integration of parts formula says that whenever we have, let me write the formula for you. Whenever we have like function of u and v getting multiplied and we have to integrate them, integrate the product. And these two functions are like dependent on x, that u is a function of x and v is also a function of x. So we'll solve them by using this method, using this formula, integration and derivative of this into integration of this and whole integration of this with dx. So what is u and v? U is the first function, v is the second function. Who is first and who is second will be decided by ILATE. It's an acronym, stands for inverse trigonometric function, logarithm function, algebraic function, trigonometric function, exponential function. So the first function, if there are two functions and if one of the function is inverse trigonometric function, so that will be considered as first function. And if there are no inverse trigonometric functions present in the product, and if there is a logarithm, then logarithm function will be considered as first. If there are no inverse, no logarithm, then algebraic will be considered. If there is not algebraic, then trigonometric function will be considered as first function. So this is the priority order for first function, selection of first function. So basically, what is first and second? First function is easily differentiable, and second function is easily integrable. That's why we are doing so. So let's go for behind and solve the. So are you able to understand? what we have discussed here. Eyelid. Should I repeat?
No, sir.
So please say so if you like have any doubt.
Yeah, sure, sir. Is there else?
Okay, so shall we continue?
Yeah, sir.
Okay, so now here's only one function. So we'll take one as another function. Now logarithm of t is not easily integrable, right? So we will take it as second function. No, sorry, first function, which is because it is easily differentiable. That's why we are going to take it as this. So writing it like closure formula, u is this, v is this. So logarithm into t, integration of 1 into dt, because t is the variable here, subtracted by integration of differentiate derivative of logarithm of t, which is 1 by t, into integration of this dt and whole integration. So the integration of 1 dt is t. So this has become t and t cancels t. So t ln t minus what is this now? This is simply 1 dt, which is again t. So this has become ln t minus 1 plus c. Now we will back substitute the value of t, which was sec inverse of x, into logarithm of sec inverse of x minus 1 plus c. This is our answer. Okay. So please remember that do not confuse integration with differentiation and differentiation with integration. It happens many a time. Okay, so this was the last example that we had to discuss. Now let's focus on your doubts if you have any, and questions or reviews or suggestions for me.
No, sir, there's nothing because this is my first class. So I just want to see what are the formulas and if is there anything I'll ask in the next class. Sir.
Okay, no problem. So if you are trying and if you're planning to be consistent in class, let me be honest with you, that for that it will be better for you that if you learn integration. Okay, and you can do so by like watching the playlist available on YouTube. The link of the same will be sent, the link of the classes recording will be sent in the group also. So there's a like playlist form and daily lectures will be uploaded there, and you can follow the previous class recordings to follow up your class levels. And even if you have any other doubt or any other question regarding your NDA as a preparation, something, then you can ask me. I have myself given ND exam 6 times and I was able to clear it 4 times and also this is week. So my experience can help and that would be a great direct from.
Sure, sir.
Okay. Shall we conclude today's class?
Yeah, sir.
Thank you. Good evening.
Thank you, sir.